Today we are going to look at sections A1.1 and A1.2. The first part of A1.1 is talking about real numbers. So this picture shows a set of real numbers, and then there's some sub-circles within that. The very innermost circle is natural numbers, which isn't included in this list. So let's just write over here. Natural numbers are your counting numbers, the numbers that you can count on your hand, like 1, 2, 3, 4, etc. Notice that there is no 0 included in this list. So natural numbers are no decimals, no 0, no negatives. Sometimes it's easier to define things by explaining what they aren't. Whole numbers are natural numbers plus 0. So whole numbers are 0, 1, 2, 3, etc. It is no decimals, no negatives, but we do include 0. Integers are still no decimals, but this time we will include negatives. So -3, -2, 0, and we would extend in both directions. So no decimals, still no decimals. Rational numbers are the first time that we include decimals. Rational has the first 5 letters spell ratio. Rational numbers basically means fractions. So this is decimals that can be changed into fractions. Now, a hint on your calculator, if you take something like 0.25, you can push the math button and then that first option to fraction, so enter, enter, and it will change that decimal into a fraction. If your calculator will change the decimal into a fraction, it is a rational number. Rational numbers are decimals that terminate, decimals that have a repetition to them, a repeated pattern, or that terminate, that end, and can be changed back into fractions. Irrational numbers are decimals that do not terminate, decimals that keep on going forever and ever and ever. For example, pi is 3.14159, and it just keeps on going and going and going forever and ever. That will not change into a fraction, so it's an irrational number. The square root of 2 is an irrational number, the square root of 5, and so on. Irrational numbers can't be changed into fractions. Rational numbers can be. Now, what you really need to notice is how these circles are arranged. So the number 2 is a natural number. It's a counting number. 2 is also a whole number. 2 is also an integer. 2 is also a rational number. It can be written as 2 over 1, and 2 is a real number. So on your assignment, it's going to give you a number and have you check boxes for, is this natural, whole, integer, rational, or irrational, and you select multiple. So when it's a natural number, it is also all of these others all the way out to that end of that yellow circle for rational numbers. If it's a whole number, it's not a natural, it isn't a whole, integer, rational. If it's an integer, it's an integer and a rational. If it's rational, just rational. If it's irrational, it's just irrational. Okay, I'm going to show this first one to you, and then I want you to do the rest of 2 and 3 on your own. Plot the numbers on a number line, and then decide which number is greater and use the symbol to show the relationship. So you should change these to decimals. So -4/3 is -1.3 repeated. -5/4 is -1.25. So here's -1, here's -2, 0 would be somewhere over here. -1.25 would actually be closer to 0, so -5/4 would be here. -1.33 would be a little bit farther away from 0, so that's where -4/3 is. So if we wrote these out, -4/3 and -5/4, -5/4 is closer to 0, so it is bigger, and the alligator eats the bigger number. Take a moment and do 2 and 3 on your own. Pause the video, do 2 and 3 on your own. Here are your answers. I tried to color code it a little bit. And 4 and 5, figure out what the decimals are. Remember, with negative numbers, the ones that are farther away from 0 are the smaller numbers. So on number 4 and number 5, transfer all of those into decimals and then put them in order from smallest to largest. There's your answers for 4 and 5. Next up is properties. Now, technically, this first property that I'm highlighting in yellow is called the commutative property of addition. But when it comes down to it, if you can tell me commutative, I don't care if it's the commutative property of addition or the commutative property of multiplication. On an assignment, you will need to look at, are we talking about addition or multiplication, and then select the correct property based on that. Commutative is all about the order in which you do things. So A plus B is the same as B plus A times B is the same as B times A. Associative is about changing the order of the grouping symbols. So adding A and B first, then adding C, versus adding B and A first. That should be a C right there, sorry. Adding B and C first, and then adding the A to it. Same thing with the multiplication. Identity basically means you're adding something that doesn't change the value of the number. So anything plus 0 is still that original number. Anything times 1 is still the original number. Inverse is what you add or subtract or multiply or divide to get back to the identity. So with additive inverse, you're trying to get to 0. So like 5 plus negative 5 is going to give you 0. Multiplication, if you're multiplying by the reciprocal, that's the multiplicative inverse. And then there's distributive property, which most of you are pretty familiar with. So here are some examples. 5 plus 2 equals 2 plus 5. We're changing the order. That is commutative. Technically, it's the commutative property of addition, but commutative. 12 times 1 equals 12. Now, the identity and the inverse ones are kind of weird. Make sure you look, you're multiplying by the identity, so that is an identity property. Number 8, we're changing the order of the grouping. We're changing how the grouping works. That is an associative property. And number 9, we're multiplying by the reciprocal. That is an inverse property. We're trying to undo the 8 by multiplying by 1/8. Okay, in section 1.2, we're looking at algebraic expressions and models. Basically, a review, 2 to the 5th means 1, 2, 3, 4, 5. 2 to the 5th means repeated multiplication, multiplying a 2 times itself 5 times. When we evaluate this, we can use our calculator. The parentheses are incredibly important. So parentheses, -3, close your parentheses, raised to the 4th. This means -3 multiplied 4 times, which gives you 81. Because we are multiplying that -3 4 times, we have an even number of negatives. Those cancel out. If we're multiplying -3 3 times, the negatives are not going to cancel. So -3 to the 3rd is going to be -27. -3 times -3 is +9. If the exponent is even, the negatives cancel. If the exponent is odd, the negatives don't. The weird thing is number 4 and number 5. Number 4, you have to do parentheses first according to order of operations. 3 to the 4th is 81, then we put that negative on it. So this would actually be -81. And this is where you have to be careful when you're using calculators, because your calculator is only as smart as the person plugging the stuff in. So you have to be smarter than your calculator. So if I type in -3 to the 4th and I don't put any parentheses in, it is assuming that I have something like number 4 here. It's going to do the exponent first, then it's going to stick the negative on there. 3 to the 3rd is 27, and then stick the negative on. That would be -27. Okay, most of you are pretty good at Pemdas. The one thing I want to draw your attention to is the Pemdas part of it, the last half. Multiplication and division are actually the same thing. So you do whichever one comes first from left to right. So if you've got a problem that has division before multiplication, you would do the division first, then you would do the multiplication. And addition and subtraction are actually the same. Subtraction is really just the addition of negative numbers. So you do them whichever comes first from left to right. Let's try a few of these out. Actually, I want you to pause the video and try 6 and 7 on your own, and then play the video to see if you got the answers correct. I highlighted what I did in each step that led me to the next step, but this was showing all of my work. And I just wanted to show you in the calculator, if you type it in exactly as you see on the page with the parentheses, that would be a good way to check yourself to see if you did your order of operations correctly. Algebraic expressions are just like numerical expressions, except that they have variables. Evaluate the expression for the given value of x. This is substituting, plugging in. So we have -3, and it may be helpful to use parentheses for some of this. So -3, anywhere that you see an x, I want you to put that inside parentheses. The -2 inside parentheses in place of the x, -5 times -2 plus 7. Then you can plug it into your calculator or do this kind of in your head. So -2 squared is 4. I can do this multiplication. 5 times -2 is -10. Or some people like to think of this more as -5 times -2, which is +10, and then plus 7, -12 plus 10 plus 7. That'd be -2 plus 7, which would be 5. You can plug this into your calculator once you get to this step if you would like. Just use those parentheses. Parentheses are your friend. Number 9, you are plugging in 4 in place of x and -6 in place of y. Give that one a try on your own. One thing to note on a problem like this is that when you have a division bar, when you have a fraction bar, that works as a grouping symbol. So you need to do the entire top to get 60, the entire bottom to get 10, then do the division to get 6. If you put it into your calculator, take a look here. I put the entire top inside parentheses and the entire bottom inside parentheses. Otherwise, do the entire top, hit enter, get that number, do the entire bottom, hit enter, get that number, then do your final division. When you have a division bar like this, you've created 2 separate groups, and you have to think about those groups individually. Simplify the expression by combining like terms. I want you to pause and see if you can do these on your own. I will show all of my steps when I do my work. On number 11, the minus in front of the 7m squared, attach that negative to it, or think of it as plus a negative, then you can combine them. Same thing on number 12. When you're distributing, this is actually a -5 that you are distributing. Don't lose that negative when you're doing that math. Okay, a few word problems to think about. You open a savings account with $300. With your new job, you figure you can deposit $75 per month. Assume that you will not withdraw money or make any additional deposits. Okay, now we are starting with 300, so we're definitely going to have 300 in that account. We are going to add to that $75 per month. Anytime you see the word per in math, that means multiply. $75 per month. 1 month, $75. 2 months, 75 and 75. That'd be 75 times 2. 3 months, 75 times 3, that money would be added in. So that's an expression. Notice I did not put an equal sign in there. Expression means no equal sign, just numbers, letters, added, subtracted, whatever, no equals. If there's an equal sign, that makes it an equation. After 3 years, how much money will the account hold? Years, this is talking about months. So 3 years is how many months? 3 times 12 is 36, 36 months. So we need to do 300 plus 75 times 36. Do that, see what you get. And then I want you to see if you can figure out part C. You might have to use trial and error, but pause the video, figure out part C, and then play the video to check your answers. For part B, you got 3,000. For part C, I thought, well, if 3 years is 3,000, I'm going to try 1 year. 1 year was over 1,000, but I want to get a little bit closer. So then I tried 10 months, and I got 1,050. So I believe 10 months. After 10 months, we would have over $1,000 in the account.